Today we are looking at what is called properties of exponents. Now you've seen these 7 rules before, so you might be familiar with some of this. We're definitely going to do some more challenging problems over the next couple of lessons. So let's take a look at the 7 properties of exponents, and we use these to simplify really big, ugly problems down to much more simpler problems. And we're going to jot down some notes as we go, so make sure you include those. The rules that we are actually going to start with are these first 3 on the right. All 3 of these have one major thing in common. They all have parentheses. And the purpose of these rules is to get rid of the parentheses. If you notice on number 5, the left side, which is where you start, has parentheses. The right side does not. Left side has parentheses. Right side does not. Left side has parentheses. Right side does not. So our goal in using these 3 rules, and these come first, okay? So let's label this with a 1. These are like your first bunch that you use. The goal of these is to get rid of the parentheses. And the easiest and most important word that we can think of, distributing. Distributing is what we are going to do here, so I'm going to make a little note of that. Distribute. And so these 2 right here are your distributing rules. So let me show you what I mean. All we are simply doing is taking this M and distributing it to both the A and the B. And make sure when you're writing it that M is an exponent and it stays an exponent. Same thing here. That M, we're distributing to both the A and the B. So it doesn't matter whether it's a multiplication problem or a division problem, you can distribute that exponent. Now, how does 5 fit in? Well, here's the thing. When we are distributing using 6 and 7, there's going to be times up here where there's already an exponent inside. And you're trying to distribute, and you're like, well, what do? There's already something there. So if there's already a number there, what operation do we think of when we think of distributing? Well, you should be thinking multiplication. So if I'm trying to distribute, and there's already a number there, you're going to take this M times this N, and that's your new exponent. So these first 3 properties, okay, distribute, distribute, and while you're distributing, multiply if you have to. Now the only time we use these 3 rules is when you have parentheses. So you've either used these or you don't have parentheses. What's the next step? The next ones we look at are 1 and 2. These are our oddballs. Okay, the first oddball says if you have a 0 exponent, the whole thing goes away and you get a 1 instead. Okay, so basically the 0 cancels what it touches. That one is probably the rarest of the rules that we use. We don't use it all that often. Number 2, this little rule is what I refer to as happy sad. I know it sounds cheesy. Exponents like to be positive. I call that happy. Anytime an exponent is positive, it's a happy exponent. If you have a negative exponent, like right here, that's sad. Well, we don't like anybody to be sad. So here's how this rule works. To make your exponent happy, all you do is take the entire thing and move it to the bottom of the fraction. And when you put it in the bottom of the fraction, the negative changes to a positive. Okay, so if you have any sad exponents, they are negatives, they are sad, we move them. And when we move them down, they become happy. Now, the other thing that's important to know, if you have a negative exponent, but it's already in the bottom, it's already in the bottom of a fraction. Well, if you have it already in the bottom of a fraction, to make it happy, you move it to the top. And then, again, it becomes happy, and the negative goes away. These 2 guys we use second. The final two that we use are these two. I call these two combining like terms. There's two ways to combine like terms. If they are side by side, you add their exponents. And if they are on top and bottom of each other, you subtract their exponents. Now, keep in mind this only applies to exponents. Okay, side by side, you add, top and bottom, you subtract. When you are done with a problem, here's how you know. Okay, you are done when you've combined all like terms, everybody's happy, and there are no zero exponents. That's how you know you are done with any one of these problems. So we're going to start out simple. One of the things we're going to do as we go along is we're going to identify what property are we using. So let's turn the page and look at our examples. First example, you should see right away that there are parentheses here. So which one of our parentheses rules does this A look like? Well, it looks like this one, number 5, because there's an exponent inside and an exponent outside. So when I distribute, which is what I'm doing, the 3, which is the big guy, the big numbers don't change. So the 3 doesn't change, but when I distribute 2 to 4, I get 8. That's one of your distributing rules. When I distribute, I multiply their exponents together. Well, let's look at B. B has parentheses. It's a distributing problem. I'm going to distribute the 3 to everything I see. Well, I see a 5, and I see an 8. So when we distribute, common mistake, people like to multiply always. This 5 is not an exponent. Do not multiply those. It is 5 to the power of 3 over 8 to the power of 3. They both get the exponent. Now that they both have the exponent, the last thing you can do is separately type them in the calculator. So I'm going to type in 5, hit the exponent button and put in a 3. The top will give me 125. Do the same thing on the bottom. 8, hit the exponent key, put in a 3, then I get a 512. You are not allowed to just type in your calculator this beginning problem. I expect to see this step, and then I expect you to do them separately in the calculator. Let's look at C. Now, C is where a lot of people would make mistakes. They see parentheses and they automatically assume it's distributing. But these are separate parentheses. And if you notice, these negative 2's are the same. This is actually a problem that looks more like this rule right here. The negative 2's are like the A's, and they each have an exponent. This is really a combining like terms problem. So when they are side by side, we add. When they are top and bottom, we subtract. Well, these are side by side. So I'm going to combine like terms. Now, when I combine them, I'm only combining the exponents. The negative 2 stays the same. And 3 of them plus 9 of them gives you 12 of them. Now, if you would like, you can again pick up your calculator, type in, and yes, those parentheses are required. Parentheses, -2, close parentheses, to the power of 12. And your calculator should tell you 4,096. So use the parentheses or else you would get a negative answer, and that's wrong. Let's look at D. Well, this is the first one where we're really combining several rules. Okay, I look and I see some 10s, but I see parentheses. And when we see parentheses, we do parentheses first. So I'm going to distribute the 4 to here. The 10 is not changing. The 4 times the 2 gives you 8. Times 10 to the power of -2. That's rule number 1. Now, we come back over here. What's the next group that we do? Next group we do is this group. And this is something new that we're going to talk about. This is the happy sad rules. This 10 has a positive 8 for its exponents. It's happy. This 10, however, has a -2 for his exponent, and he's not happy. So here's what we do. We're going to start a new line, and we're going to put a fraction bar. If it's happy, it stays where it's at. This first 10 was happy, so I'm going to leave him on the top of the fraction. However, this 10 is not happy. He's going to move to the bottom of the fraction, and when I move him and his exponent, the negative is going to go away. So down here in the bottom, I now have 10 to the positive 2 power. So now, we've made this guy happy. He's positive now. However, we're still not done with this problem because these 10s are the same. And our rule says we are not done until we've combined all like terms. So remember, side by side we add, top and bottom we subtract. These are on top and bottom, so we're going to subtract. Now the only thing that's subtracting are the exponents. Again, the 10 ain't changing. 8, take away 2, leaves me with 6. And then finally, you can type in your calculator, 10 to the power of 6, and you should get 1 million. So make sure that when you're doing these problems, you're showing me your steps. Now, these were all ones that had numbers to work with. We're not always going to have numbers. Most of the time, you're going to have letters, and to me, the letters can actually be a little easier to work with because you don't mess up on your rules. So let's look at the next pair of examples. Okay? So, first thing I see on A are parentheses. And so I know I need to distribute. So I'm going to take the 7 now. It gets distributed to all the big guys. Well, the big guys are the A and the B. So we're distributing twice. Now, when I am distributing to A, 7 times 2 is 14. Now I'm going to do the B. 7 times 3 is 21. That's the distributing part. Now we ask ourselves, is everybody happy? Well, that's positive, and that's positive, so yes. So then we ask ourselves, are there any like terms? Are A and B the same? The answer is no. So we cannot combine like terms, which means this is done. So let's take a look at B. What do you not see on B? There are no parentheses. So we're not worried about distributing on this one. So those first set of 3 rules, we're not using at all. So if we're not using those 3 distributing rules, the next thing we're asking is everybody happy? And the answer is no. This B is not happy. So I'm going to draw a fraction bar. And remember, if they are happy, they stay on the top. If they're sad, they go to the bottom. This guy, happy, stays on the top. And this guy, happy, stays on the top. That A, happy, stays on the top. That B is sad. We need to move him to the bottom. And when we move him to the bottom, the negative is going to go away. So down on the bottom, it's B with a positive 7. So now everybody's happy. So now the last question is there like terms? And the answer to that is absolutely yes. So I'm going to draw a fraction bar. My first pair of like terms are these A's. Well, are they side by side or on top and bottom? And the question is, they are side by side. So when they are side by side, we add. So 4 A's plus 8 A's leaves me with 12 A's. Now here's my question. Where are they located? Well, right now they're on the top of the fraction bar. So they stay on the top of the fraction bar. A to the power of 12. Well, we have another pair of like terms. This time we have some B's. We got a B and another B. Are they side by side or top and bottom? This time they are top and bottom. That means we subtract. Now here's the tricky part. When we subtract, always start with the larger amount. 7, take away 3, leaves me with 4. The question is, where do those 4 B's belong? It always goes where the starting amount or the larger amount was. The larger amount's on the bottom. Those 4 B's go on the bottom. That's important. When you're subtracting, you put the leftovers where the bigger number is. And that is a done problem. So let's try some more. We're going to keep trying examples because these are definitely tricky. So let's take a look at A. What do you see right away? I see parentheses. What do parentheses mean? Distribute. So I'm going to distribute this 3 to both large guys, to both the A and the B. If you have a fraction bar to start with, keep the fraction bar. On the top, A, 3 times 2 is 6. On the bottom, we got the B. 3 times negative 3 is negative 9. And again, if you're not good with your multiplication facts, you have a calculator. So we've distributed. Second question, is everybody happy? Answer is no. We need to move one of them. This guy right here, not happy. Keep your fraction bar. Is A happy? Yes. Where do I put him? I keep him where he's at on the top. Is B happy? No. Well, here's the thing. He's in the bottom. If he's in the bottom and he's not happy, we have to move him to the top. So I'm going to move this whole part to the top, and the B, the 9 changes to a positive. There's nothing left on the bottom, and that's okay. There doesn't have to be. And then the last question is, now that everybody's happy, did you combine all like terms? And the answer to that is yes. So let's look at part B. Do we see any parentheses? Yes, we do. We start by distributing. This 5 distributes here. So this is y 5 times 2 to the power of 10. I'm not distributing with these. I'm just going to keep them and bring them down. Next question. Is everybody happy? And the answer to that is no. We have one of the y's, this last one, that is not happy. Draw me a fraction bar. Is this guy happy or sad? He's happy. He stays where he's at on the top. Is this guy happy or sad? He's happy. He stays where he's at on the top. Is this guy happy or sad? He's sad. He's going to move from the top to the bottom and change from a negative to a positive. So that's like question number 2. Is everybody happy now? Let's look at question number 3, combining like terms. Well, there's 3 things to combine here, but you can't do them all at one time. So we're going to start, I always tell people, it's easier to start with the top. So I'm going to keep my fraction bar. I'm going to start by combining this y and this y. Well, are they on top and bottom? Are they side by side or top and bottom? Those two are side by side. So I'm adding. Well, 10 y's plus, how many y's are there? Hopefully you're saying, well, there's 1. And that's absolutely correct. If you're missing an exponent, it's always a 1. 10 plus 1 makes 11 y's on the top. Well, we still have 12 y's on the bottom. So we are not done combining like terms. Now we are going to combine this top y and the bottom y. Well, I just said they were on top and bottom, which means we are subtracting. We know we always start with the bigger amount, which is 12. 12, take away 11, leaves me with 1. And where is the bigger amount right now? On the bottom. So on the bottom of the fraction, I have 1 y left over, but you can never have a naked numerator, so that blank up here is just going to be filled in with a 1. And then people ask, is this 1 right here necessary? No. You could have also written this as just 1 over y. I will take either one of those answers. So, those are what we consider so far some of the simpler problems. We're going to look at some of the harder problems now. So, let's go through our steps. First question, is there any parentheses? Answer to that, no. Second question, is there anybody here that is sad? And the answer is yes. So I'm going to draw a fraction bar. And we're going to go one item at a time. First thing that's important to know, this 9 and this A are separate. So is the 9 happy? Yes. Leave him on the top. Is the A happy? Yes. Leave him on the top. Is the B happy? Yes. Leave him on the top. Now we get to the second chunk of stuff. Is the -3 happy? This is the number one biggest mistake. Everybody likes to say, no, he's not happy. But he is. The only thing that cannot be negative are exponents. Is -3 an exponent? And the answer to that is no. He is a regular, plain old whole number. So I'm going to keep him on the top. Is the A after him happy? No. That's a negative exponent. So we're going to move the A to the bottom and make him happy. Is this B happy? No. He's also going to move to the bottom and become happy. So everybody's happy now. Third question, is there like terms? Yes. Let's start with some A's. I see an A here, and I see an A here. Fraction bar. Are they side by side or top and bottom? They are top and bottom, which means we need to subtract, starting with the larger amount, which is right here. 9, take away 3, leaves me with 6 extras on the bottom, because there's more on the bottom. Next pair of like terms, we got some B's. Well, are they side by side or top and bottom? Again, top and bottom. Where's the larger amount? On the bottom. 12, take away 6, leaves me with 6 B's, and they go on the bottom because there's more on the bottom. What's the last thing we have left? Well, the last things we have left are a 9. Change this with that color. Our 9 and a 3. Well, these guys are special. Those are not exponents. They are whole numbers. And so we need to treat them like whole numbers. Well, if nothing else was there, if you took your hands and you covered up all those A's and B's, the only thing you would see left is 9 times negative 3. And that's exactly what we're going to do. What is 9 times negative 3? It's negative 27. And since both of those are on the top, the negative 27 goes on the top, and that is done. Whole numbers can be negative. Exponents cannot. So let's look at B. Same questions. Any parentheses? No. Anybody who's sad? Yes. New fraction bar. Starting with 24, happy or sad? He's happy, he stays on the top. Is A happy or sad? He's sad, he's going to go to the bottom and become happy. B, happy or sad? He's happy, he stays on the top. Going to the bottom. Is this 6 happy or sad? It's happy, so it stays where it's at on the bottom. Is this A happy? Yes, he stays where he's at on the bottom. Is this B happy? No, so he needs to move from the bottom to the top to become happy. So B is now on the top, and that's a happy 3. So everybody's happy now. The last piece of the puzzle, combine like terms. Make your fraction bar. First, if you like to start with the letters, we got some A's right there. Notice I did not highlight the 6. Are these A's side by side or top and bottom? They are side by side, which means we are adding. So 3 A's plus 5 A's gives you 8 A's, but they go on the bottom because that's where they are at. There are 8 A's on the bottom. What do you want to combine next? Well, I see some B's. I see a B here and a B here. They are also side by side, which means we are also adding them. 15 plus 3 makes 18 B's. Where are they located? They are on the top, so they go on the top. Last piece of the puzzle, we have a 24 and a 6. Again, those are whole numbers. If you took away all the A's and B's, all you would see left on your paper is 24 divided by 6. And that's exactly what we are going to do. 24 divided by 6 is 4. And where does that 4 go? Wherever the bigger number is. It goes on the top. And this is a done problem. So those are definitely some of the more challenging ones. Let's keep going because we got some more examples. Hopefully by the end of this lesson you're going to think, oh my gosh, I get it. Let's look at A. Do you see parentheses? Yes. We need to distribute. But where do you see the parentheses? I see them only on the bottom, which means I'm only distributing on the bottom. This 3 is going to get distributed to both the R and the S. Keep the top exactly the same. R, S squared. On the bottom, the 3 gets distributed to the R, and it becomes R to the power of 3. Then, for the S on the bottom, 3 distributing to the S, 3 times -1 is -3. So yes, it's okay to only distribute on the bottom. Pay attention to where your parentheses are. Now, is everybody happy? No. Make your line, but one at a time. Is this R happy or sad? He's happy. Keep him on the top. Happy or sad? He's happy. Keep him on the top. R on the bottom. Happy or sad? He's happy. Keep him on the bottom. Is this S on the bottom happy or sad? He's sad. So he's going to move from the bottom to the top and become positive. Final thing, is there any like terms? And yes, there are. First pair of like terms, let's go with some R's. These are one on the top, one on the bottom, which means we subtract. So start with the larger amount, 3. How many am I subtracting? Well, hopefully you remember again, that is an imaginary 1. 3, take away 1, leaves me with 2. Where are they located? The bigger amount's on the bottom, so those 2 R's are on the bottom. Other pair of like terms, we got some S's. This time, they are side by side, so we add 2 S's plus 3 S's, make 5 S's, and they go on the top where the S's already are. And that is a done answer. Let's look at one more together, then I want you to at least try a couple on your own. So, we have, again, parentheses, which means we need to distribute. This 3 gets distributed to all the A's and B's. It gets distributed to the A on the top, B on the top, the A on the bottom, and the B on the bottom. Any large item is what it gets distributed to. So let's start with the top. A on the top. 3 times 2 makes 6. B on the top. 3 just goes with the B. There's nothing there, so now there's a 3. A on the bottom, moving to the bottom. 3 times -1 is -3. And the B on the bottom, 3 times 5 is 15. So just make sure you draw an arrow to every single large item. Anybody sad? Yes? Make a new fraction bar. Starting at the top. Happy or sad? He's happy. He stays at the top. B is happy. He stays at the top. A, going to the bottom. A is not happy on the bottom. So where does he go to become happy? He goes to the top. What about the B? B is happy on the bottom, he stays on the bottom. Finally, do we have any like terms? Yes, we do. We got an A and an A. They are side by side, which means we add. 6 plus 3 makes 9 A's on the top. Now we got some B's. These are on top and bottom, so we are subtracting. Start with the larger amount, 15. Take away 3, leaves me with 12 B's. The bigger amount's on the bottom, so those 12 B's go on the bottom. And that's the end of that example. And so now I would like you to pause the video, try these two on your own. Okay, so let's see how you did. First, I see parentheses, which means distribute. Now, this might have been where you made your only mistake. When we are distributing the 2, most people just go right here. It does need to be distributed to the B, but the 7 and the B are separate, so it also needs to be distributed to the 7. So that might be one of your mistakes. So when we are distributing the 2 to the 7, that 7 is a whole number. We are not multiplying. It is 7 to the power of 2. Now let's distribute to the B. 2 times a negative 3 exponent is a negative 6. Then we keep these other 2 guys that we have in the problem. Next, is everybody happy? No. Make your fraction bar. 7 squared is happy. He stays on top. This B, sad. He's got to move to the bottom and change from a negative 6 to a positive 6. This B is happy. He stays on the top. This B is also happy, and he also stays on the top. Next question, do we have any like terms? Yes, we do. There are a pair of B's right there. People ask me, well, how do I know, because there's 3 B's, how do I know which ones to start with? I start with the ones that are side by side. To me, it makes it easier. So, not using this guy, he tags along. 5 B's plus 1 B makes 6 B's on the top. This guy tags along to the bottom. Is there any more like terms? Yes, there still is. We now have this B on top and that B on the bottom. Six B's take away 6 B's. Well, what happens when it's the same amount? Well, what's 6 take away 6? Well, it's 0. And the one rule that we really haven't seen yet is the rule with 0. If you get a 0, it cancels. These basically cancel out. Because 6 take away 6 is 0. So what's really left? 7 squared. And what's 7 squared? Because yes, we can get an answer here, and we need to get an answer here. 7 squared is 49. So we went from having a whole bunch of B's to ending up with a whole number. And yes, that's okay. So let's see how you did on part B by yourself. Hopefully you distributed only on the top though. That 2 goes to the X. The 2 also goes to the Y. So X on the top, 2 now goes with that X. Y on the top, 2 times 2 is 4. X stays on the bottom, and he tags along. So we carry it along. We've distributed. Next question. Is everybody happy? Answer is no. Make a new fraction bar. Starting at the top. He's happy on the top. Y is also happy on the top. Moving to the bottom. This X is happy on the bottom. This Y, however, is not happy on the bottom. He needs to move to the top and change to happy. Finally, do we have some like terms? And the answer to that is yes. Let's start with our X's. There's an X on top and there's an X on bottom. Starting with the larger amount, that would be 3. 3, take away 2, leaves me with 1x. There's more on the bottom, so it goes on the bottom. And we have another pair of like terms. We got these two y's. They are side by side, so I'm going to add 4 plus 1 makes 5 y's. They stay on the top right there. And we are done. Okay, so let's look at the final problem, probably the most challenging of them. Because you look at it like, oh my gosh, there's a whole bunch of stuff here. And we're going to do it together. I'm going to make this a lot simpler for you. Take this fraction bar and just go all the way across with it. And there's multiplication on the top and multiplication on the bottom. Make it one giant problem. Because if there's one giant problem, then we can put all the rules together. So first question, parentheses, no. Second question, is everybody happy? No. So that's where we're going to start. We're going to move people around. On the top, 9, happy. X is happy. Y squared is happy. Times 4 is happy. X to the 5th is happy. Y to the negative 3, not happy. That's the first one we got to move. He moves from the top to the bottom and becomes happy. Moving to the bottom. 3 is happy. X is not happy. So that X is going to move to the top and change to happy. Times 6 is happy. Y is happy. So everybody's happy now. Combining like terms. There's a bunch of them. So here's the easiest way to tackle a problem like this. Only combine like terms on the top and only combine like terms on the bottom. Don't mix yet. So let's look at the top. On the top, I have a 9 and a 4. Let's just start with the whole numbers. Because they're whole numbers, 9 times 4 is 36. Next pair, we got an X, and an X. 3 X's. And we're going to put them all together because they're all on the top. When they are side by side by side, we add. 1 plus 5 is 6, and 6 plus 1 makes 7 X's on the top. Is there anything else on the top? There's this Y. He has to stay in the problem, but he doesn't have any like terms. So just bring him along. We're going to do the same thing on the bottom. So on the bottom, is there any like terms? Let's start with some whole numbers. 3 and 6. 3 times 6 makes 18 on the bottom. Is there any other like terms on the bottom? Yes. We have a Y and a Y. They are side by side. So 3 plus 8 is 11 Y's on the bottom. So that kind of made life a little easier. We're not done, but it's much simpler now. We still need to combine like terms. Now we're going to mix top and bottom. First pair, I'm just going to start with my whole numbers. 36 and 18. Whole numbers, 36 divided by 18. Well, what's 36 divided by 18? It's 2. Where do I put that 2? Well, where's the bigger number? It's here on the top. So the 2 is going to go on the top. What else do we have that's like terms? Well, I see some y's. Here's a y, and here's a y. Top and bottom means we are subtracting. So starting with the larger amount of 11, 11 take away 2 leaves me with 9 y's. Where's the bigger amount? On the bottom. Those 9 y's go on the bottom. Is there any other like terms? No. Is there anything left? Yes. This x just stays on the top over here. And that is a done problem. That's the hardest you're going to see, and I'll see you in class.